Okay, question 31. So x equals tan inverse t, y equals ln t. Find the expression for dy dx. So we need to do dx dt here. Now tan to the minus 1t is in the formula booklet. Okay, so in the formula booklet it's written like this, isn't it? On the differentiation page. Okay, that's all it is, right? Now, because of course we've got t here, so there'll be 1 over 1 plus t squared. Okay, and dy dt then will equal to 1 over t. Okay, because ln t differentiate, you get 1 over t. Now remember, dt dx is what we need, so you need to flip this. So that's easy then, because you get 1 plus t squared. And then it says then part A, find dy dx. So dy dx then will be dy dt times dt dx. So dy dt is this, 1 over t. dt dx then is this, which is 1 plus t squared. Okay, so you get then 1 plus t squared over t. Okay, and that's our answer for dy dx. Part B then says find the value of x for which d2y by dx squared is equal to 0. Right, so we need the second derivative here. We need to differentiate this again, right? So if we differentiate this again, we need to think carefully about how we can go about this. Now what I would do here is, I'm going to differentiate this again, maybe split this up because it'll be a lot easier. You can think of it as a quotient if you want, right? Do it as a quotient, so, you know, u and v there to differentiate it, but it might be easier because we're dividing all the top by t. You can split it up. You can think, okay, well this divided by 2 is the same as 1 divided by t plus t squared divided by t. Okay, it might be easier to do that. And then you get 1 over t plus t, yeah, because that t will cancel with the square there. Okay, so to get the second derivative there, you want to do d by dx, isn't it, of dy dx, okay? I don't know, I've written dt there, by dx there, isn't it? So d by dx of dy dx. Now of course d by dx of dy dx, well this is 1 over t, okay? I'm going to write that as t to the minus 1 plus t, okay? But you can't differentiate this with respect to x, okay? You've got to do it with respect to t. So dt, and then plonk a dt dx on the end. So now we can differentiate this. Okay, we can differentiate this. So bring the minus 1 down, and then that becomes 1 there. T becomes 1. And dt dx, going back to the start then, is 1 plus t squared. Okay, that's what dt dx is. So we get then, we could write this as, what could we write this as? We could write this as minus 1 over t squared plus 1 times then 1 plus t squared. Alright, we could leave it like that. We could multiply out. Okay, there's lots of different options we've got here. So then let's look at what the question's asking for. It says find the value of x for which d2y by dx squared is equal to 0. Well, if this is d2y by dx squared, if we put this equal to 0, okay, it may be better actually to leave it as 2 brackets. So when it's equal to 0, we can say, look, both brackets are equal to 0. Okay, and if both brackets times equal to 0, it gets back to that quadratic sort of thing, and you say, look, either one of them is 0. Okay. Okay, so you've got that situation going on. Now with this second situation, I can see straight away this is going to be an impossible situation, isn't it? Because that means you take the 1 over, you get minus 1, t squared equals minus 1. It's impossible. Okay. Okay, so we can instantly dismiss that. This, obviously, here should equal 0. Okay. So if we got that equals to 0, we'll have 1 equals to 1 over t squared. Okay. And then take the t up, so t squared will equal 1, which means t will equal plus or minus 1 when you square root it. Now I'm just looking here to see, because it says find the value of x, right? So there's only one value of x we're interested in. Okay, so it's important you look for the language there, for which this is equal to 0, but it also says as well if t is greater than 0. So we've got to say then t equals 1, okay, because t has got to be greater than 0. And when t is 1 then, right, all you do then is you sub it into our x to work out the x value that they want, so we put it into there, alright? So you've got x equals then tan to the minus 1 of 1, okay? So you get your calculator and you can put that in there in radian mode, and you get your answer. Of course then the answer comes out as a quarter pi, right, or pi over 4. Okay, and that's it, we're done.